Mode extraction is a technique for computing multiple modes of an electromagnetic cavity. Mode extraction works through data analysis of the dumps of data from a simulation. It works even when the frequency resolution implied by the length of time of the simulation is too small to resolve the modes. In this tutorial, we run through a complete simulation setup and calculation. We start with new simulation. We can describe this simulation under the description part of the element tree. The descriptions are for your convenience and records. Now I have actually saved these in another window so that I can copy and paste them into place. So I will bring up the other window, copy the short description, and paste it into the text box. Upon hitting return, you will see that the title bar description has changed to what is the short description. Now I will get the regular description, and finally I'll get the long description. The descriptions are intended to be successively more detailed, but it is entirely up to the user to set those as desired. Now at this point, I move to save this work. So I go to the directory where I want to save it. I click on a file name that's close to what I like. That puts it in the Save As box. And then I change it to the number that I want there, 0, as being the starting point for this successive set of simulations. Once I have the name the way I like it, I can move my mouse to the bottom of the Save File dialog and hit Save. Next, we will import the geometry. In this case, c100_export.stp, a step file. Upon opening that file, it is digested, and ultimately we are asked whether to resize the grid to the new bounds. By selecting yes, we end up with a new grid that surrounds that object with just a small margin. A particularly good view for this simulation is the plus y view, that is to say, looking along the minus y direction, and we can see the cavity better by unclicking the grid. The STP file that we received in this case defines the inside of the cavity. That is to say, this shape is surrounded by perfect electric conductor, or PEC. We need to tell VSim that this is the case. So we go to Basic Settings, we select the PEC property, and we change it from solid by double-clicking, and we change it to hollow. Now we go to the database, we select PEC, and we add it to our simulation so that it can be used in the shapes of our simulation. At this point, I like to go back to the 3D view. So now I'll look at the cavity, and I see that cavity 1 has two shapes underneath it. I can see what they are by clicking on them, and then what's over at the right gets highlighted. And I can see that it's the first shape that I want. That's the actual cavity. And so now, I'll save my work before going further. I'll go back to where I was and set that to the next, or -1, input file of the simulation. As you can see, it takes a little bit of time. It is busy as it saves that simulation and all of its associated files. So now I have the basics of my cavity set up. We will now conclude here and go on to the next movie in the tutorial.